Ladies and gentlemen, welcome back to the Workplace Scientifics YouTube channel. I'm Dave Lombardi, your host for this video. And in today's video, I want to talk about local exhaust ventilation, commonly referred to as LEV systems. Now, I dare say many of you have got these on your sites as part of course, the control measures for your processes. But I just want to go through a few bits with those systems, almost address a few myths, if you will. I'm not going to go into how you test them. I'm not going to go into why you need them in detail because I dare say you probably already know that or you've come across it. And in the future, we'll also do a few more videos around those specific topics. But for the purpose of today, I just want to give you a few little nuggets around appropriateness and effectiveness. Two massive words there in the world of LEV, because the misconception is that you can just buy an LEV system off the shelf or take it from one place and put it onto another process elsewhere. There's this concept that an LEV system is just an LEV system. It'll pull air through. Okay, great. Yes, I agree to a certain extent, it will just pull air through. But bear in mind, the purpose of an LEV system isn't just to pull air through, it's to pull contaminated, dirty air through, i.e. it's there to control those hazardous substances, that airborne, dust, fume, whatever it might be. Hence my words, I want to talk about appropriateness. That LEV system must be appropriate for the environment, for the task, for the process, and it must also be efficient. What do I mean by efficient? Well, what I'm getting at is, and it's something I talk about when I do the professional courses, what I'm getting at is there's a massive, massive difference between an LEV system performing an LEV system performing effectively. What I'm saying here, ladies and gents, is an LEV system can perform if it's designed to pull 5 meters per second at the hood face. It can do that all day long. But just because it's working, just because it's performing, does not make it an efficient control measure. Please bear in mind, it's not there to just look pretty and shiny. It is there for a purpose, and that purpose, of course, is to control the exposure of those workers at a localized position, i.e. LEV, local exhaust ventilation. So when I talk about the effectiveness, yes, it does link to the performance. It needs first and foremost to be able to operate within the design parameters and the parameters that's required for that process, that operation. Say, for example, 15 meters per second throughout the ductwork in terms of transport velocity, and maybe 5 meters per second at the face of the hood. But when we talk about effectiveness, it's that effectiveness of controlling and drawing in that fume, that dust. And a big part of that, a massive part of that, and you've heard me talk about this in previous videos about provision of information, instruction and training, and ultimately human behavior. For an LEV system to be effective as a control measure, it must incorporate, of course, the user, the person actually there working with it. So that person must first and foremost understand what that system's there to do. How does it operate? How does it function? What's its purpose? That individual must also understand how to move it along. They must understand how to make sure it is effectively controlling the exposure. Just a little side note, what am I talking about when I'm saying controlling exposure? What I'm really, really saying, guys, it's looking after that person and that person's health who's using it. So that individual, that worker must understand that not only do they need to switch it on, but of course they need to reposition it, especially if it's a captor hood. I'll come back to the style hoods in a minute. But if it's a captor hood, of course it needs to flow, it needs to move with the actual process, or guess what? It's not going to be effective. So positioning of the hood is absolute critical. And that is critical, and as I talk about this, 3 scenarios come to mind. It's absolute critical in the first design stages, especially if it's a larger system that's got a potentially fixed or semi-fixed position of a hood. That position is absolute key, and that's what makes it effective. The other one to consider here as well is the use of mobile systems, little mobile dust carts you may have come to see. So we need to understand, of course, the positioning around those hoods, because as they are moved around different positions, they of course need to be positioned in the correct way. And who's going to correct it in the put it in the right position? Sorry. Well, of course, it's that worker who's using it. So they need adequate training to, of course, make sure that they can pull it through. That third scenario that comes to mind, I've seen this plenty of times over my career. Again, I've been doing this for 20 odd years now. The other scenario is when an LEV system is either relocated or there's a change to a process and there's an assumption that actually it'll just work. Well, it might perform, but it might not necessarily be effective as a control measure. So understanding, ladies and gents, what an LEV system is, what that specific system is capable of doing, how people use it, and the training they need to understand why they're using it. That's a massive thing, the why, and also what to do in the event it doesn't work properly. Absolute critical bits of information, guys. And my little parting shot, before I move on to the next part I want to talk about, it's a concept I've said a few times, and it's that concept that one size fits all. But actually it doesn't. And that's still very applicable in LEV systems as well. Forget the mobile units for a second. Again, they come with their own issues we need to overcome. But generally speaking, an LEV system is designed for a specific process, specific material, specific flow rates, specific area. Hopefully you're getting the gist here, ladies and gents. It's designed specifically for a given situation. So based on what I've just said, one size fits all? Well, actually it doesn't, because an LEV system is designed for a specific thing. And a lot of the systems I looked at over the years, I failed a lot of them when I've gone to test them and do a thorough examination and test. I failed them because, yes, they might perform, but they're not providing effective control because they've been relocated or the process has changed or they've not been maintained. Hopefully you get the gist, ladies and gents. As I mentioned just a second ago, mobile carts, mobile units, absolute massive in terms of human interaction, human behaviors, a heavy amount of human reliance to ultimately make it work properly. So we need to make sure they are done in the right manner. Which then brings me nicely on to how do we know that they're actually effectively controlling exposure? Well, as I'm sure you've maybe come across, you must have that system thoroughly examined and tested at least once in a period of 14 months, as per Regulation 9 of the COSH regulations. So again, it's not just if you fancy it, you must, by law, again, the COSH regulations, by law, you must have those systems thoroughly examined and tested by a competent, properly qualified individual. And it's that individual, through that testing, will be able to demonstrate and tell you if the system's doing what it should be doing. Also, when you're getting your LEVs tested, not only should you be doing the performance element to it, there's also two other stages as well. Actually, the performance element is stage 2. Stage 1 is looking at, is the system in a good condition? Is there any defects? Is there any problems, physically damage or anything like that? The third end to it is demonstrating that effective control, usually undertaken by air monitoring. So you've seen a previous video, I dare say, hopefully by now, when we've talked about exposure monitoring, looking for chemical hazards. Well, the measurement methodologies around how we do that link very much into what we do when we test LEV systems. So to demonstrate the ability of that system to effectively control exposure, we also need to quantify what is airborne. So again, it all links together. So that reminder, ladies and gents, the key bits, make sure you get them tested at least once in a period of 14 months. Make sure it's thoroughly examined and tested, looking at the individual components in terms of what are they like, what's their condition. Do the performance testing, i.e. your face velocity readings, the transport velocity measurement, static pressure, the like. We'll talk about that in another conversation. And of course, finally, the key one really, making sure it's effectively controlling exposure. All three must play a part. So LEV system testing, again, that thorough examination and test, as I've just mentioned, and some of you may all be thinking, actually watching this video, why every 14 months? Well, let me tell you, it's every 14 months because in theory, every time, so when my guys go in and test an LEV system on your behalf, they may turn up in January. The following year, they'll turn up in March, May, July. You get the gist. The reason for that, and if you think about as you go through the seasons of the year, what we're actually changing is the environmental conditions. I'm sure it's not lost on you all. In the height of summer where it's really warm, all the windows will be open, the doors will be open, all the shut doors will be wide open, you've got cooling fans. You've got a nice flow of air naturally moving through the building. Consider that in terms of the height of winter where it's cold. Doors are shut, windows are shut. All the fans have been switched off, you've now got heaters on. So you're now changing the environmental conditions. That is why it's every 14 months, ladies and gentlemen. Please be mindful of that. So that's the end of my conversation for today. I hope you've enjoyed listening to this video. I hope you've got some useful information out of it. As always, do get in touch if we can support you and help you with your LEV testing. If it's due anytime soon, please do feel free to get in touch. Our details are below. Drop us an email, give us a call, and we're more than happy to talk you through and help and support you with your LEV testing. Thanks very much for listening, guys. Look forward to seeing you in the next video.